a standard spectrometer, a glass prism, and a monochromatic light source are used to determine the refractive index of glass. Part A. A few necessary adjustments are to be done to the spectrometer before starting to take the measurements. Part 1. What is the adjustment that should be done to the eyepiece? In spectrometer, there are three main parts: telescope, collimator and prism table. First of all, we have to adjust the telescope. There are two adjustments related to telescope. First adjustment is eyepiece length. Second adjustment is objective length. When adjusting eyepiece length, we have to adjust the eyepiece length such that we can see clearly crossfire. Then we have to write adjustment related to eyepiece length is adjust the eyepiece to see crossfires clearly. Then part 2, telescope is pointed to a distant object and it is adjusted until a clear image of the object is formed on the crosswires. What is the purpose of this adjustment? We have to write the purpose of adjustment related to objective length. We can write to get image formed by focusing parallel rays on crossfire. We know that the rays emitted by collimator are parallel rays. There is a slit in collimator and it produces parallel rays. This is the collimator. And we have to adjust telescope to obtain parallel rays to make an image on crossfire like this. An image should be formed on crossfire and we can see the image on crossfire. The crossfire should be placed at this place. We can see the image on crossfire by using the eyepiece lens. This is the eyepiece lens. You have to write only the answer, but I have drawn the corresponding ray diagram. In part 3, what is the adjustment that should be done to the slit of the collimator? We have to adjust the width of slit of the collimator by using screw in collimator. Then we can write answer for part 3 adjust the width of slit. Adjust the width of the slit. Then part 4, the telescope is brought in line with collimator. Then the collimator is adjusted until the sharp image of the slit is formed on the crosswire. What is the purpose of this adjustment? We have to write the purpose of adjustment. We can write to obtain a parallel beam by using the collimator. Then we can write answer for part 4 to obtain parallel rays. To obtain parallel rays. Then part B, in order to level the prism table, the prism is placed as shown in the figure 1 and the screws P, Q and R are adjusted. Part 1, when the telescope is at position T1, the screw Q is adjusted to obtain symmetric image of the slit on crosswire. When the telescope is moved to position T2, which screw should be adjusted to get symmetric image of slit? I will draw the diagram roughly to explain. There are 3 screws in prism table, P, Q and R. And these 3 screws are in an equilateral triangle. Then we have to place the image such that the side of prism is perpendicular to a line joining 2 screws, and prism angle should be placed near to the center of the prism table. And we can use partially reflected rays to obtain 2 situations corresponding to the telescope. This is the telescope. There are 2 positions. We can see at this place and this place the image of slit by using partially reflected rays. These rays are not fully reflected, partially reflected. They have given this position as T1 and this position as T2. And they have given that at T1 position, the screw Q is adjusted to obtain the symmetric image. When see the slit by using telescope at this position, the slit is not symmetric if the prism table is not leveled. Therefore, we can adjust Q, we can rotate Q screw to get symmetric image like this. The image of slit should be symmetric on the crosswire. Then we have to move telescope to this T2 position, and again we have to rotate the screw to get symmetric image. They have asked that what is the screw we have to rotate. We have to rotate screw P to obtain symmetric image at T2 position. And we have to do same steps again to get symmetric image at this place and this place by the telescope. Then answer for part 1, B part 1, we have to adjust screw P. It is easy to obtain symmetric image by using by adjusting Q and P for the position T1 and T2. We can decide it. Q and P screws are the two screws. We have to adjust parallel light beam is parallel light beam comes to the collimator is between Q and P screws. Then we can adjust Q and P screws again and again to get symmetric image by the telescope for this position and this position. In part 2, a student stated that the leveling the Prism table could be easily be done using the split levels. Is this statement correct? Briefly explain the answer. We know that we can level a horizontal plane by using a split level, but we can't use split level to level the Prism table for this practical, because of we have to level the Prism table relative to collimator and telescope. We can't get a level position relative to collimator and telescope by using the split level. Therefore, we have to write answer for part 2 is no. We have to level Prism table relative to collimator and telescope. In part C, when the telescope is at T1 position and T2 position, the readings of the spectrometer are 279 degrees and 58 minutes and 38 degrees and 2 minutes respectively. Note that telescope passes the zero of the main scale when it is moved from T1 to T2. Calculate the Prism angle. When calculating Prism angle, we have to draw the rough sketch of positions of telescope. We know that 0 degrees, 90 degrees, 180 degrees, 270 degrees and 360 degrees for these 4 positions. The first reading is 279 degrees and 58 minutes. It is a position like this. 279 degrees, 58 minutes. Second reading is 38 degrees and 2 minutes. It is between 0 and 90. I will mark it like this. 38 degrees and 2 minutes. When finding Prism angle, they have given that when rotating telescope, the main scale 0 is passing. Therefore, we have to calculate this angle. When calculating this angle, we know that this part is 360 degrees minus 279 degrees and 58 minutes. We have to subtract this value from 360 to get the magnitude of this part. And we know that this angle is equal to 38 degrees and 2 minutes. It is the direct reading. Then we can add this angle and this angle to obtain this full angle. It is theta. Theta means the angle between two positions of telescope. Then theta angle is this angle. We can obtain theta angle by adding this value and this value. But prism angle is this one. When calculating prism angle, we have to divide theta value by 2. Then we can write prism angle is theta divided by 2. We can get theta value 360 degrees minus 279 degrees and 58 minutes. This angle is this part. And we have to add 38 degrees and 2 minutes. To obtain theta, then we have to divide it by 2 to get the prism angle. Then I will calculate it. Then subtracting angles with minutes, we have to convert this angle. We can write it 259 degrees and 60 minutes. We know that 1 degree 60 minutes. Therefore, we can get 1 degree from this side to minute side. Minus 279 degrees and 58 minutes plus 38 degrees and 2 minutes. Divide by 2. 10 minus 8, 2. 5 minus 5, 0. 2 minutes. 9 minus 9, 0. 5 minus 15 minus 7, 8. This one is 359. 2 minus 2, 0. The difference of these two angles, 80 degrees and 2 minutes. We have to add 38 degrees and 2 minutes. Then we can divide by 2. 2 plus 2, 4. 4 minutes. 0 plus 8, 8. 8 plus 3, 11. Divide by 2. 11 divided by 2, 5. 1 remaining. 18 divided by 2, 9. 59 degrees and 4 minutes divided by 2, 2 minutes. 59 degrees and 2 minutes. It is the prism angle. Then part D. To determine the angle of deviation of light rays by the given glass prism, a student measured the incident and emergent angles I1 and I2 respectively, as shown in the figure. The graph shows the variation of I2 and I2 with I1. Part 1. Write down an expression for the angle of deviation D in terms of prism angle A and angle I1 and I2. The incident angle, it means angle between ray and perpendicular line. For this surface, it is I1. This angle is I2. We have to get the angle of deviation. Angle of deviation means this angle. This is the direction of incident ray. This is the direction of emergent ray. The angle between incident ray and emergent ray is the angle of deviation. When calculating angle of deviation, we can get refracted angle for first surface is R1, second surface R2. And we know that this angle and this angle 90 degrees, angle between prism surface and perpendicular line. And we know that this opposite angle of this quadrilateral is supplementary. Sum is 180, 90 plus 90. Then it is a cyclic quadrilateral. Therefore, this exterior angle of cyclic quadrilateral should be equal to interior opposite angle. This prism angle is equal to this one. Then we can consider this triangle. When considering this triangle, A is the exterior angle of triangle. It is equal to sum of interior opposite angles. Then we can write A equals R1 plus R2. Now, we have to get the deviation. Deviation equals to deviation from first surface D1, this angle, and deviation from second surface D2. Then we can write D equals D1 plus D2. Total deviation is deviation from first surface and deviation from second surface. We can write D1. D1 is this angle. We know that this I1 angle equals to this full angle, vertically opposite. Then we can write D1 is I1 minus this part, it means R1. We can write D1 I1 minus R1 plus, then we can get D2. D2 is, we know that this R2 angle equals to this part, vertically opposite. Then D2 is this full angle I2 minus R2. I2 minus R2. Then we can simplify it. I1 minus R1 plus I2 minus R2. I1 plus I2 minus R1 minus R2. Then I will get I1 plus I2 minus R1 minus R2. Then I will get minus marked as a common factor from these two terms, R1 plus R2. We know that sum of R1 and R2 equal to A according to this equation. Then we can substitute prism angle for this part. Then angle of deviation is I1 plus I2 minus sum of R1 and R2 is prism angle. This is the relationship we have to write for part D. Then part 2, determine the minimum angle of deviation D by using the graph. We know that for the minimum angle, minimum deviation, the right ray should be symmetric through the prism. It means I1 should be equal to I2. We have to obtain the I angle related to symmetric ray. We can get symmetric ray by using the graph. I1, I2. They have given a graph like this. Don't draw the graph. I will explain by using the image. We have to get I value for the symmetric angle. When getting symmetric angle, we can draw 45 degrees line of graph like this, and we have to obtain value corresponding to this point. We can get this value and this value. Those are same values. Then it is the I value for minimum deviation. It should approximately equal to 47 degrees and 30 minutes. They have given marks for all values between 47 and 48. but the correct value is 47 degrees and 30 minutes. 47.5 degrees, it means 47 degrees and 30 minutes. Then we can write I value for symmetric ray 47 degrees and 30 minutes. We have to draw the 45 degrees line and we have to get the x value or y value corresponding to this intersection point. It is 47 degrees and 30 minutes. Then we can write minimum angle of deviation. Minimum angle of deviation is capital D. We can write these two values are same. Therefore, I plus I minus A. I plus I means 2I minus A. 2 times 47 degrees and 30 minutes minus A is the prism angle. We have obtained the prism angle in previous part, 59 degrees and 2 minutes. Then we can simplify it. I will multiply 2 times 30, 60 minutes equal to 1 degree. Then we can get it as 1 degree. 2 into 7, 14, 14 plus 1, 15, 1 remaining. 2 into 8, 2 into 4, 8, 8 plus 1, 9. 95 degrees, 0 minutes. Minus 59 degrees and 2 minutes. Then we have to get 60 minutes to this side by subtracting minutes. We can write it 94 degrees and 60 minutes minus 59 degrees and 2 minutes. I have brought 1 degree from degree side to minute side. Then 58 minutes. 14 minus 9, 5. 8 minus 5, 3. 35 degrees and 58 minutes. It is the minimum deviation angle. Part 3. Calculate the refractive index of glass that the prism is made. When calculating refractive index, we have to use the equation of minimum deviation. We know that refractive index is sin A plus D over 2 divided by sin A over 2. It is the angle for minimum deviation. Then we can substitute. We have to find refractive index. Sin A value is 59 degrees and 2 minutes. D value is this one. It is the minimum deviation angle, 35 degrees and 58 minutes. Divide by 2. Divide by sin A is prism angle, 59 degrees and 2 minutes. Divide by 2. N equals sin 2 plus 58, 60. It means 1 degree. 9 plus 5, 14 plus 1, 15, 1 remaining. 5 plus 3, 8 plus 1, 9. Sin 95 divided by 2, divide by sin, I will divide this value by 2, 59 divided by 2, 5 divided by 2, 2, 1 remaining, 19 divided by 2, 9, 8, 18, 1 remaining, 1 degree means 60 minutes, 60 plus 2, 62 divided by 2, 31 minutes. Then 95 divided by 2, sin 9 divided by 2, 4, 1 remaining, 15 divided by 2, 7, 1 remaining, then 1 remaining, it is 1 degree, we can get it as 30 minutes, 60 minutes, 60 minutes divided by 2, 30 minutes. divided by sine 29 degrees and 31 minutes. Now you can find sine values and after dividing by using sine values we can obtain it is approximately 1.49. Refractive index of glass is 1.49.